Hello everyone, welcome to Pep Coding. In this video, we will look at the question container with most water. Okay, so in this question, we have n numbers and we have heights at those numbers, right? And we have to make a container from those heights, or we will have to choose two lines and we will have to make a container of those two lines such that if I fill that container, right, if I fill that container completely with water, then I will get the maximum capacity. So let's say I choose this line and this line. Okay, if I choose 6 and 5. So if I fill this completely with my water, right, I will get a container like this, or I will get a container with something like this capacity. Okay, if I try to fill this more, it is going to overflow. So this will only be my capacity. Now let's say I take this and this, right? If I take these two lines, then this will be my point, right, till which I can here fill my container. So this will be my container height, right, and I can fill it here. Similarly, if I take this and let's say this, right, then this will be my height, so I can fill this only till this point. So I have to return the maximum capacity which I can get from choosing these two lines. Okay, I have to I have to choose different lines and I have to compare them to get the maximum value of the capacity. Okay, so what is going to be the brute force approach, right? If I just use a brute force approach, the brute force approach is going to be that I take a number I and I take a number j, right? I take I and I take j, and for I, j will travel for every number, right? So if I is sitting at 0, then j will go to 1. Okay, we will have a pair of 0 comma 2, then a pair of 0 comma 3, 0 comma 4, 0 comma 5, and so on, right? Then I will move to 1 and j will start from 2, right? Then we will have 1 comma 2, 1 comma 3, 1 comma 4, and so on. So we will have these multiple pairs. We will do this thing for multiple number of times, right? Then when I comes to 2, then j will start again from 3, 4, 5, 6, 7, 8, right? So this is not a very good approach. What we are trying to do is we are trying to find every single pair and we are trying to compare those two pairs, right? We are trying to find every single pair and we will compare those pairs to see which one gives me the maximum water, right? Which one gives me the maximum capacity. And I am doing that by checking all the pairs. So this is not a very good approach. Okay, what I'm trying to do is I'm trying to compare every single pair and I'm trying to find every single pair and I'm trying to compare every single pair. So my brute force approach way is going to take me O of n square complexity. Why? Because if I have n numbers, then I'm traversing n elements n number of times. Okay, so it is going to take me O of n square. Now, what is going to be my optimized approach then? Optimized approach. Let's discuss about the optimized approach. Let's say I take a pointer I here and j here. And before going into the whole thing, let's discuss what is going to be my height and my width. Okay, my height is going to be what is going to be my height? My height is going to be the minimum of the two numbers, right? The minimum of, let's call this height of I and height of j. Why it is going to be the minimum of the two numbers? Because I know that the value of the capacity or value of the container, or let's say the capacity of the container, will be the minimum of the two values, or the height of the container will be the minimum height of the two values. So let's say I take this 2 and this 6. Okay, I have 6 and 4. So if I take these two values, then my container will be of this much height, right? And I can fill this like this with water, right? I can fill this like this. If I choose 6 and 8 as my two numbers, right? Let's say I use two different numbers. Let's say I use 8 and 7, right? I use these two numbers. Then if I use these two numbers, my height is still going to be the minimum of the two, right? So because if I try to go over it, it is going to overflow, right? So I can only fill till the minimum point or the minimum height of the two numbers. So my height is going to be the minimum of the two numbers or the two heights. What is going to be the width? Width is just going to be the range between the two. So if I have I and j, the range between the two will be j minus I. So my width is going to be j minus I. So just my new water will be height times width. That is going to be the water. Okay, or let's call this most water. This is going to be the most water. Okay, so now we know how the height of the container will work, how the width of the container will work. We just need to find the maximum height or the maximum water that we can get. Okay, so let's take these two pointers I and j. Right, we have I at the beginning position and j at the end of the vector or end of the array list or array. Now we have this I and j. Now we have to increase this I and or decrease this j on the basis of something, right? I have to increase this I or decrease this j. And before moving on, before going somewhere else, let's just try to calculate the height, width and the water at this position only. So I'm at 1,7, right? When I'm at 1,7, my height is going to be, or let's just call this h. My height is going to be the minimum of the two, which is 1, right? My width is going to be 8 minus 0, which is 8. So my water will be 8 at this point, right? Water will be 8. So at 1,7, my water is going to be 8. Now, this is not my right answer, right? So I need to increase my I or decrease my j to get the right answer. So what can I do? Let's say I can do two things. I can increment my I or decrement my j, right? I can do these two things. And here I know that I am at 1,7, right? I am sure of this thing. And my I is at the minimum height, right? Not the minimum height in the whole array, but only the minimum height comparing in the two numbers. So between 1 and 7, I is minimum, right? And j is at maximum height, max height. So what we will do is we will see what I and j can do on the basis of increasing or decreasing. Okay, let's say if I increase I, there are two things that can happen. Either height will decrease or height will increase or height will decrease, right? If I increase my I, then either my height can increase or decrease. Okay, so these are the two things that can happen. If my height increases, my width is going to decrease only, right? Whatever I do, my width will decrease. Why? Because my width is a range actually, right? My width is the range between the two numbers. And if I increase my range, if I decrease my range, then my width is definitely going to decrease. If I increment my I, my range was here before, right? Now it is from here to here. So my range will always decrease. So whatever happens when my height is minimum, if I increase my height, if I increase my I, then either my height will increase or my height will decrease, but my width will decrease regardless. Okay, if my height decreases and my width decreases, then I can say for sure that my water will also decrease, right? But if my height increases and my width decreases, then there is a slight possibility when my water is going to increase or my water can increase. Okay, there's a slight chance that my water can increase. So let's say I'm at this 1,7, right? If I increase this, I will be at 8,7. So my height has increased, right? So there's a chance that my container capacity will also increase. Now let's discuss this for J. What will happen if we do the same things to J? If we decrease J. So if we decrease J, then either two things can happen. Height can increase or height can decrease, right? But my width will decrease regardless, right? Because the range is decreasing. So if my height increases and my width decreases, listen to this, okay? This is the max height at this point, right? This is the max height at this point. And if I decrease my J, if my height increases and my width decreases, my water will also decrease. And if my height decreases, width decreases, my water is also going to decrease. Now, why is this happening? Why I can say that when my height is increasing and my width is decreasing, my water is also decreasing when J is maximum or when my height is max. Okay. So let's say I'm at this point, I'm at 1,7, right? When I'm at 1,7, the container that I will have will be something like this, right? This will be my container. This is 1 to 7, right? This is the container that I will have when my I is at 1, J is at 7. Let's say I reduce my J. Okay, I'm reducing my J because we talked about the minimum height, right? We already know about the minimum height, that if I increase my I will get to 8, and there is a chance where my container is going to increase in capacity. But now I'm talking about J only because J was maximum height, right? So if I decrease my J, then there are two things that can happen, right? Height will decrease, width will decrease, so the water will also decrease. What I'm saying is, now the height has decreased. Height is equals to 3. But has it really changed anything? You see that if I decrease my height, or if my height decreases, and before my height was maximum, then it really didn't make a change, right? Because the height of my container, is dependent on the minimum height of the two, right? The height of my container is dependent on the minimum height. So here, the height of the container is still dependent on this one, right? The height of the container is still dependent on this one. The only thing that has changed is the range, right? The change on this doesn't really make any difference, but the change has been made on the range. And since we reduce the range, the water capacity will also reduce. Okay, let's say this was a little different. Let's say this was, instead of having 3 here, we had 10, right? Or let's say we had 9. So if we had 9, we would add something like this, right? But now, if we decrease this J, or let's say this was my old container, and if we reduce this J now, right? If we reduce this J, now my new container will be like this. Is there a difference between this container and the value where it was 3? There is not a difference, right? Because it is still dependent on this one. This one is still my minimum. So the maximum capacity is dependent on the minimum height, right? If I have my maximum height, and if I reduce my maximum height, then if I reduce my maximum height, then my water will always decrease. But if I have my minimum height and if I increase my minimum height, right, there's a slight chance, if I have my minimum height and if I decrease or increase my minimum height, or minimum height, no, I'm talking about the pointer which is pointing at the minimum height. So if I can either increase or decrease my pointer, and on the basis of that, there's a chance where my water can increase, right? But if the height is already maximum between the two, and if I reduce the maximum height, then my water will decrease always. Okay, so that's what I'm saying, that it doesn't really matter if the number here is 9 or 3. It doesn't really matter if my height increases if it was maximum before. Okay, so we will always decrease, or we will always increase our I or decrease our j when my height is minimum. Okay, when my height is minimum of the two numbers. So let's try to code this and then we will dry run this approach so you can understand this way more better. Okay, so we are at this point. Okay. So first we need our I and our j. J will be heights dot length minus 1. Okay, now we will have a water and we will return this water. Here we will have our algorithm. So while I is less than j, because when I and j are equal, let's say I and j are equal here, at this point, we will have only this one line, right? And we cannot make a container from this one line. So my base case will be, or my while condition will terminate when my I is equal to j or it is greater. Okay, so while I is less than j, till then, find the height, right? So I'm trying to find the height of the container. The height of the container will be the math dot minimum value of the two numbers, right? So heights of I comma heights of j, right? This will give me the minimum height. Now I need the width, and my width is just j minus I, right? And what is going to be my water? Water will be the math dot max value of the two numbers, right? So the old water and height times width, right? This is my new water. Now the only thing left is I had to either increment my I or decrement my j, but it is dependent on the height, right? So if height of I is less than heights of j, then there is a chance that if I increase my I will get more water, right? And else, if heights of I is equals to height of j, or if heights of j is smaller than heights of I, then I will decrement my j. So I'm only making a change when my height is smaller, right? I'm only making the change when my height is smaller. This looks fine. Let's run this code. It's taking a lot of time. Refresh the page. Okay, it is accepted. Okay, let's submit this code now. Okay. So it is submitted. It is the right answer. Now let's try to dry run this. Okay. Let's take this here. Okay. So now we will have my height, or my I was at 0, j was at length minus 1, right? So length minus 1, and my water was 0 at first. Okay. So let's say what is my I is at this point, my j is at this point only, right? So let's remove this as well. So my height is going to be the minimum of the two heights. So I 1 and 7, right? So my height is going to be the minimum of the two heights, 1 and 7. 1 is the minimum height. Width will be j minus 1 or j minus I, which is 8 minus 0, right? Which is 8 only. Now my water will be the maximum of the old water and the current water. So my water will be, old time it was 8. Now my water is 8. So it will increment to 8. Okay. Now my heights of I is less than heights of j, right? 1 is smaller than j, 1 is smaller than 7. So I will increment my I. Okay. Now my new height will be the minimum of the two heights, which is 7. Okay. The width will be 8 minus 1, which is 7. Right. So 7 times 7 gives me 49. 49 is greater than 8. It will change to 49. Okay. Now my j is smaller. Right. Heights of j is smaller. So I'll decrement my j. Now I have 8 and 3. Smaller is 3. Right. The width will be 7 minus 1, which is 6. 6 3s are 18. It won't change. I will decrement my j because it is smaller. Right. Both are equal. Height is equals to 8. 6 minus 1 4. 6 minus 1 5. 8 5s are 40. 40 is not greater than 49. So I will decrement my j again because I and j are equal. Right. 8 and 8 are equal. And I said that if heights of I is less than heights of j. So it doesn't really matter when they are equal, right? I can increment I or I can decrement j. Okay. So I'm decrementing j. I have 1 and 5 or 8 and 4, right? My height will be 4. My width will be 5 minus 1, which is also 4. 4 and 4, 16. 16 gives me 16 is not greater than 49. So I will decrement my j because it is smaller. Then I have 8 and 5. 5 is smaller. My height will be 5. I have my width as 4 minus 1, 3. 5 3s are 15. Right? It won't change. J is smaller. It will reduce. I have 8 and 2. Okay. So 2 is smaller. And my width is going to be 3 minus 1, which is 2. Right? So my new water will be 4. 4 is not greater than 49. So I will reduce my j again because it is smaller. Then I have 8 and 6. Height will be 6. My width will be 2 minus 1, which is 1. Right? And now my new water will be 6 times 1, which is 6. And 6 is not greater than 49. So I will not change my 49. I will reduce my j. I is equals to j. So this loop's terminated. Then I have 49 as my answer. Okay. So I hope you understand this question. If you don't, I would suggest you watching the part which you don't understand. Don't forget to like, share and subscribe. Thank you for watching.